Good morning, afternoon, evening, whenever you're watching this. Most likely evening. That's what I'm guessing. All right, I'm just going to move this little paper around a bunch. So, measuring segments. Here we go. 1.2. So we talked about a lot of our basic geometry pieces like lines and points and planes and all that stuff. Now we're going to talk about their measure because we need to talk about how long and ways to calculate their measures in order for us to continue on this beautiful path of geometry. So, number one, the distance between 2 points A and B can be written as the length of AB. And notice that's a segment there. I didn't put arrows on it. Or we sometimes just say AB. Okay? And so this one we can count. It is 1, 2, 3, 4. 4 units right there. Okay? Congruent segments. Congruent segments. If AB is equal to CD, then the segments are congruent. And this is written as AB segment is congruent to CD segment. So basically what we're kind of saying is this equal sign right here is referring to the same measure. So they have the same measurement, like AB is 4 and CD is also 4. So they have the same measurement, and this then allows us to say that we have congruent shapes. And this word here, congruent, really just means, if we were to think about it, congruent means it's the same shape and same size. Okay, so if you and I were congruent, we'd be the same shape and same size. And when we write congruency, we use the equal sign with this little squiggly above it. So that's a congruency sign. So when we do equal, we're talking about the measurements the same. When we do congruency, we're talking that the shape itself is the same and the size is the same. Okay? So there you go. All right. Segment addition postulate. So segment addition postulate is pretty cool. If we have A, B, and C that are collinear, meaning they're all on the same exact line, and B is in between them, so see B is in between A and C, that means that AB plus BC, right, so those two segments, so this segment and this segment right here, when you add them together, you should get the entire segment, AC, which is this whole thing right here. Okay? And this we call a postulate. So postulate simply just means that it's pretty widely accepted and understood. Like, we didn't need to prove this. In geometry, we have what are called theorems, which are things that we can actually prove. Postulates, it's kind of like so basic that, of course, it just makes sense. I always say a little piece plus a little piece makes the big piece, right? And this is pretty common, right? If I had a Snicker bar, I broke into 2 pieces, and then I put them back together, I'd have the whole Snicker bar. And that's all segment addition postulate really is, okay? And then we run into some examples. So we're not going to do every example here. I'm going to actually just skip to number 3 right here, and it says, if EG, now this is where highlighters are very important. So EG is the whole thing, and EG is 71. All right, so basically we have to find some sort of equation that we can create to then solve for x. And that's really a huge part of geometry is, can I create an equation so I can then solve for x? Well, I know this little piece, I know this little piece, and I know the whole thing. Can I set up an equation? The answer is yes, I can. If I actually take this guy right here in yellow, and I take, say, this little piece in green, yellow plus green should add up to the pink segment. Okay, so yellow, and then we go maybe plus the green segment, should equal the entire segment in pink. And that's called our segment addition postulate. So we get 8x minus 17 plus 5x minus 3 equals 71. Okay, now we just do some basic algebra here. We're going to combine like terms. So 8x plus 5x is going to give us 13x, and negative 17 and negative 3 is going to give me negative 20, and that will equal 71. Then all I have to do is start trying to isolate x. So I'm going to add 20 to both sides, and we'll get 13x equals 91. Divide by 13, and x will equal our final value of 7. Okay. So again, we're trying to set up these equations for ourselves to find what they equal. And this is going to be a similar case of 4, 5, and 6. And we'll look at some of those in class. On the back. Okay. On the back, here we go. Midpoint of a segment. Okay, so let's look at the midpoint of a segment. So the midpoint of a segment is a point that divides a segment into two congruent segments. Okay, remember, congruent means same shape, same size. So a line, a ray, or a segment that intersects a segment at its midpoint is said to bisect the segment, and it's called the segment bisector. Okay, and then it says in the diagram to the left we have B is the midpoint of, so what's the midpoint of? Well, notice that we see AC. This is what we call a congruency mark. Okay, it means congruent. Okay, so let's go ahead and identify that real quick. That's a congruency mark. It means congruent. Okay, so that means AB and BC are congruent to each other. Okay, so B is really bisecting our segment AC, and the line L, okay, which is this line right here, we could call a segment bisector because that whole line is kind of bisecting AC. Okay, what does this look like in practice? What does this mean? Well, the key word, when we hear midpoint, you want to think cut in half. Okay? When we get cut in half, that means we get two congruent parts. So, again, vocabulary gives us information on how to set up equations. So midpoint, so this is now my midpoint Q. That means all of a sudden I should mark that this segment and this segment have become congruent. Now, it asked me to find PR. I don't have any information about PR. Unlike the other one over here, we knew how big the entire segment was, so we could just do this plus this equals the whole thing. Segment addition postulate, great. Over here, I have this and this, but I don't know what PR is. I don't have a value. I don't even have an algebraic expression like 3x plus 5 or something like that. So I can't set up an equation that way. But what I can do is if I know PQ is congruent to QR, that means these pieces must be equal to each other. So all I really have to do is take 7x minus 16, set equal to 4x plus 2. And that's what midpoint means. So I'm going to move my x's to the same side, so I'm going to subtract 4x over here. I always move the small person. This becomes 3x. I'm going to move the 16 away, so I get 18 on the other side. And then divide by 3, x equals 6. Now it says find the value of x. I am done. Okay? Could I find PR? Yeah, let's just do it real quick, because sometimes it asks you to do that, like in these ones right here. It asks you to go ahead and find something. So to find PR, I just have to plug it back in to one of these equations. So if I take 7 minus 16, now I'm not going to plug in x, I'm going to plug in 6. Okay, so we get 7 times 6, So 7 times 6 is 42, minus 16. I'm using a calculator off the screen just to help myself. So 26 is the value of PQ. Well, if PQ and QR are the same, that means QR is also 26. And using segment addition postulate, little piece plus little piece should equal the whole piece. So that means 26 plus 26, if we were to add those up, we should get our final answer of 52 is our length of PR. And that, my friends, is measuring segments.